Hey everyone, sorry I can't be here today to show you this in person, but if you just follow along with these notes, it's the same thing that I would have done with you. So, our last section in this unit on triangles is on isosceles triangles, which we've learned about at the beginning of this unit, and how isosceles triangles, remember, are triangles that have at least two congruent sides. I want to talk about the parts of an isosceles triangle. So first of all, the two sides that are congruent are called the legs. So the legs are the two congruent sides. So if these were the two congruent sides, the legs would be here and here. So those would be the legs of the isosceles triangle. The angle where the two legs meet is called the vertex. That's the vertex. The side opposite the vertex is called the base. And then we have something called base angles. The base angles are the angles where the legs meet the base. So this one here and this one here. So those are the parts of an isosceles triangle. Our first theorem from this section says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. The angles that they're talking about are the base angles. So if you look at this picture here, if these two sides are equal, it's these two angles that are equal as well. So that's the first theorem. So if we look at this little bullet here, it says this theorem basically states that the base angles of an isosceles triangle are congruent. So if we have this triangle here, it says given isosceles triangle ABC, which angles are congruent? So see if these are the legs, the angles opposite the legs would be A and C. So we can say angle A is congruent to angle C. And so we would use this theorem to solve problems with and without algebra. Okay, so let's take a look at example one. So example one here, we're given that these two sides are congruent, so that means these two angles are congruent. So if this one's 68, then that one is also 68. So x is just 68. Pretty easy. Example two, if these are the sides that are congruent, these would be the angles that are congruent. So if this one's 40, this is called the vertex angle. And these are the base angles. Remember that all three of them add to 180. So if we do 180 minus 40 to get 140, that's what the sum of these two. And these are equal. So if we just divide this in half, we would get that these two angles are both 70. The last one here has some algebra. So again, our goal is to be given these legs and be able to figure out which angles are equal. So this one and this one would be equal. So if this one is 3x plus 3, this one is 3x plus 3. And now we think about what do we know about these three angles in the triangle? They add to 180, right? So this plus this equals 180. So we can do 3x plus 3 plus 3x plus 3 plus 5x minus 2 equals 180. And so since all of this is on the same side, we want to combine like terms. So 3x, and 5x, that's 6x plus 5x is 11x. And then 3 and negative 2. So that's 6 minus 2 is 4. So now we're here, and then we're just solving for x. So we have to subtract that 4. So 11x equals 176. And now divide by 11. So 176 divided by 11 is 16. Remember too, once you get your value for x, if you needed to find any of the angles, we could just take 16 and plug it in. Okay, so that's the front. So let's go on to the back. So now there's something called the converse of the isosceles theorem, which if you remember what a converse is, it's basically you're flipping the if and the then. So this theorem says that if two angles are congruent, then the sides opposite those angles are congruent. So what that means, I'll draw a little picture here. So now we'll start off with the angles, and then we have to figure out which sides are congruent. So if I gave you a picture and said these two angles are congruent, we could conclude that this side is congruent to that side. So it just goes in the opposite direction. So if you look at these examples, example 4, if these two angles are congruent, then these two sides are congruent. So all x is 7. There's like no math to be done here. It's just identifying that they're the same. Okay, example 5, one with algebra. If these two angles are the same, these two sides are the same. So what do we know about these sides? We know that they're equal. So we're going to set them equal to each other. And then we solve for x. We have to bring the x's on the same side. So 6 equals 1x minus 6, and then add 6. So x is 12. Again, if I asked you to find TV or SV, you would plug it in. Okay, that's the converse of the isosceles triangle theorem. And now we have two corollaries. A corollary basically is just something that stems from a theorem. It's just like a rule that we follow, pretty much. So the first one says a triangle is equilateral if and only if it's equiangular. We've talked about that. So basically, if all the angles are the same, all the sides are the same, and vice versa. If all the sides are the same, all the angles are the same. If you want to write that in like regular language, you can. So if all sides are equal, all angles are equal. And then if you have an equilateral equiangular triangle, all the angle measures are 60. Remember, because they have to add to 180, and if they're all the same, 180 divided by 3 is 60. So that's if you have an equilateral triangle, they're all 60. Okay, so we have a couple examples with these. So this first one, see how all the sides are the same? So that means all the angles are the same, which means they're all 60. So this is 60, this is 60, this is 60. So you could do 6x plus 6x plus 6x equals 180. But since we know that they're all 60, we can just set that one angle equal to 60. Divide by 6 to get x is 10. Pretty easy. It also goes in the opposite direction. So if I know that all three of these angles are the same, I know that all three of these sides are the same. So if this one's 7, so is this. So what do we know about them? We know that this one equals this one. So we can do 6x minus 5 equals 7 and solve for x. So we can add 5. 6x equals 12, divide by 6. X is 2. If I also asked you to find the length of this side, it would be 7. They're all 7 because this one's 7 and it's equiangular. So that means it's equilateral. Okay, so down here, if you want to try these three on your own, maybe pause the video and then come back and watch how you're supposed to do them. That would be a good idea. Or if you need some more help with it, you can just keep going and don't pause it at all. So number 1, remember that if these two sides are the same, we need to figure out which two angles are the same. It's the angles that are opposite the sides. So this one and this one would be the same. So if this one's 54, that one's 54. So to find x, these three add to 180. So if we add 54 and 54, that's going to be 108, and then subtract that from 180. So x is going to be 72. Number 2, if these two angles are the same, these two sides are the same, what do we know about them to solve for x? We know that they're equal. Whoops, 13 equals 2x. Remember that sides don't ever add to 180. So if you're given sides, a lot of times they end up being equal to each other. So I'm going to bring this 3x over here so we can get the x's on the same side. So that 2x minus 3x is going to be negative 1x. And now we have to divide by negative 1 to get that x all alone. X is 13. Okay. And then lastly, this one, we're given that it's an isosceles triangle and one of the angles is 60. So if you have an isosceles triangle and one of the angles is 60, you could conclude that all three of them are 60, making it equilateral and equiangular. And so why that's true is, say we didn't know that rule, right? And we just know it's isosceles. That means that these two are the same. So if we do 180 minus 60 is 120, and then do 120 divided by 2, we end up getting 60. So all three of them end up being the same. So based on these corollaries, if all three angles are the same, all three sides are the same. So what do we know about these? They're equal to each other. They're not equal to 60. That's kind of a common error with this. The angles are 60. The sides are not. The sides are completely different. So we're going to set these equal to each other. 2x minus 1 equals 3x minus 7. Solve for x. So I'm going to bring the 2x over. Negative 1 equals 1x minus 7. Add 7. I ran out of room. So x equals 6. That's number 3. So that's isosceles triangles. We will do practice of this next class. I will check next time that you did the proofs packet and that you filled in these notes. We'll take our quiz on triangle proofs and then we'll do practice on isosceles triangles. That's the plan. All right, if you have any questions, please let me know and hope you guys have a great day.